Generative AI creates new content from user prompts, utilizing neural networks to learn complex structures from massive datasets. It provides multimodal output, generating text, images, audio, video, code, and professional designs. Applications span content creation, business automation, education, and research. Generative AI follows a complex, multi-stage process. The first stage, learning and building, involves collecting data, training neural networks, and creating a foundational model. Data is the foundation of generative AI. It requires multimodal inputs, enabling pattern recognition across large datasets. Quality control is critical, as poor or biased data leads to flawed AI results. Training is where the model learns patterns from data through neural network analysis. It involves relationship mapping and predictive intelligence, ultimately creating the model's base intelligence. The foundation model is the versatile core created after large-scale training. It offers general-purpose utility and can serve as a multimodal foundation for various types of content. It provides the scale and versatility for modern AI. Tuning adapts the base foundation model for a specific task. This improves accuracy and relevance for specialized use cases, ensuring consistent reliability for deployment. Tuning bridges the gap between base logic and specialized performance. Fine-tuning uses task-specific data, like labeled examples and prompt answer pairs, to significantly boost domain-specific performance. This helps the model follow preferred formats and excel at niche tasks. RLHF, or Reinforcement Learning with Human Feedback, uses human judgment to improve AI responses. This involves human review, correction for safety, and expectation alignment, leading to superior model interaction. Prompting is how humans interact with and control the AI. A prompt provides instructions for intent and generation, offering contextual guidance for tone and direction. Quality engineering, or crafting better prompts, leads directly to higher quality AI outputs. Generation is the creation of new content. It involves pattern synthesis and multimodal output. Output quality depends on the prompt to ensure the result is relevant. Generation is the culmination of the AI's training and instruction. Evaluation and retuning improve the output over time. This includes quality assessment, safety monitoring, and feedback integration. Retuning makes the model more reliable through continuous refinement. RAG, or retrieval-augmented generation, connects the AI to external knowledge. It uses retrieval and context from documents or databases to reduce hallucination and provide verified, source-based answers. RAG ensures factual grounding with real-world data. Generative AI models are evaluated on 3 key factors: quality, diversity, and speed. Quality ensures outputs are accurate and clear. Diversity ensures varied outputs for different styles, and speed measures the ability to produce results quickly for practical use. Major categories of generative AI models include variational autoencoders, generative adversarial networks, diffusion models, transformer-based models, and multimodal models. These categories represent the different approaches to content generation. Variational autoencoders, or VAEs, use an encoder-decoder architecture. The encoder phase compresses input data into a latent representation. The decoder phase rebuilds data, or generates new variations. VAEs were foundational in early generative AI progress. Generative adversarial networks, or GANs, use 2 competing networks: a generator that creates content and a discriminator that acts as a judge, checking if the content is real or fake. This adversarial training improves both networks, making GANs excel at realistic image and synthetic data generation. Diffusion models create content through a reverse noise process. During training, noise is added to the data. Then, through reverse diffusion, the model learns to iteratively remove this noise step by step, which results in exceptionally high quality and detailed images for design and editing. Transformer-based models, the foundation of modern LLMs, use an attention mechanism to focus on important parts of the data. This provides contextual understanding and efficient processing through parallelization, making them ideal for summarization, translation, and advanced chatbots. Multimodal models process and unify more than one data type simultaneously, such as text, images, and audio. They are built on foundation architectures to handle cross-modal relationships, producing rich, context-aware outputs useful for modern AI assistance and content creation. Generative AI is reshaping industries by automating and improving work across sectors. Its applications span creative content, complex modeling, and personalized experiences across multiple fields. In language and text systems, generative AI excels at content creation, generating high-quality articles and summaries. It offers linguistic versatility for translations and chatbot replies, and is capable of generating and debugging programming code. Audio and speech systems use generative AI for music synthesis, composing original melodies across diverse genres. It also produces natural voice narration and creates specialized sound effects for media production, enhancing entertainment and accessibility. Visual content systems use AI for image and logo synthesis, creating photorealistic art and branding assets. They also generate cinematic video clips and smooth animations, and produce detailed 3D models and avatars for gaming and virtual environments. Generative AI is vital in creating synthetic data for AI training. This scalable dataset creation helps overcome real-world data scarcity. It aids in bias mitigation and stress testing, all while protecting sensitive user information through privacy and compliance measures. Generative AI applications are found across core service sectors like marketing and software development. They accelerate scientific and technical frontiers and drive personalized learning platforms in education and entertainment, enabling a new era of cross-industry innovation. Key benefits of generative AI include increased velocity for fast content creation, enhanced creativity for brainstorming, greater intelligence for decision-making, and improved customer experience. Ultimately, it drives innovation and process optimization. Challenges of generative AI include high computing costs and generation speed limitations. Issues also arise from data quality and scarcity, as well as legal and copyright risks. Furthermore, human oversight is critical to manage bias and hallucinations. Deepfakes are AI-manipulated images, videos, or audio that falsely represent actions or statements. They are misused for misinformation, impersonation, and fraud. Detection and user awareness are vital defenses against these realistic AI manipulations. Responsible AI requires a human-in-the-loop approach with constant human review. Users must commit to accuracy, verify information independently, and protect data privacy. Upholding integrity and fair use means avoiding deepfakes and plagiarism to ensure AI is fair and accountable. Thank you for engaging with this video on generative AI. We appreciate your time and hope you gained valuable insights into these complex models and their applications.